Hey guys, we're just going to have a look at the three examples of our exponential functions that we did in class yesterday. Okay, so the first one is sketching via transformations. Now we've been doing a lot of this lately. Oh, I'm going to put a negative out there just for fun. Okay, all right. Now remember the approach. So if we had something like y equals 3 sine x minus 4, we would always get our base function, use that as a control, and graph y equals sine x, and then do our transformations, do any dilations first and translations after we've done our dilations. So we're going to do the same thing here. But our base function here is 2 to the x. So the first thing I'm going to do is graph my control y equals 2 to the x. Okay, so let's do that. Y equals 2 to the x. 0, 1, when x equals 1, 2 to the power 1, 2 to the power 2 is 4, 2 to the power 3 is 8. There we go. 2 to the power of negative 1, half. There we go. So plot a few points there, and there is our control graph, y equals 2 to the power x. Okay, now let's look at our transformations. We've got 3 here. We've got a dilation. We have a reflection. And we have a horizontal translation. Okay, so the first two, the reflection and the dilation, doesn't matter which one you do first. Okay, I tend to like doing the dilations first, but you can interchange. So let's do it. So I would be doing first dilation. So I'm going to do my times 2, double all my points. Then I'm going to do my reflection. That's the negative reflection in the y-axis. And then I'm going to do my vertical translation of 3 units down. Now, if you wanted to interchange those and do the reflection first, then the dilation, that's okay, that'd work. It's just always easier to do those first and do your translations last. Okay, so let's have a look. Let's do our dilation of 2. So every point here, I'm going to double. So 1 will become 2. A half will become 1. 2 will become 4. 4 will become 8. 8 will become 16. Okay, so here is my I've just done this one here. My dilation times 2. Notice asymptote is still the y-axis. It's just approaching, still the x-axis. It's approaching the x-axis, but just a bit slower. And, of course, we have doubled our y-intercept. Our y-intercept now, instead of it being 1, is now 2. Okay, so now let's do our reflection in the y-axis. So I'm just going to take these points and literally put them on the other side. So this point here goes over to there. This point here goes to there. When x is 2, that's going to be negative 2, 8. When x is 3, it'll be negative 3. There we go there. So here we've got our, and that one doesn't go anywhere. Okay. Once again, still approaching the x-axis. And now I'm going to do my last one, my vertical translation 3 down. So I'm going to think of my key features. First one being the asymptote, so I'm going to move that down 3. 1, 2, 3. So here is my asymptote. And now I'm going to take each key point on my red graph and move it down 3 places. 1, 2, 3. 1, 2, 3. Just moving down 3. 1, 2, 3. 2 down 3 will take me to -1. 2, that will take me down one more, and so on. So here we go. If I join those dots after I've done my vertical translation, here's my final function. There you go. And there we have it. Y equals -2 times 2 to the x minus 3. Okay. In an examination situation, which you will be in soon, okay, and you'll be doing graphical transformations and you'll have lots of graphs there. I recommend getting a highlighter and making sure you emphasize which is the one that you want your marker to be looking at. Don't erase all the others because we can then see how you're getting to your final graph. Okay, that's an important part of your working. Okay. By the way, just a couple of observations. What is our y-intercept now? Our y-intercept now is -1. And what's our asymptote? It is this green line down here, which is the graph, the line y equals -3, because it went down from 0 to -3. So there's our two key features. Right, let's have a look at the next one. Right, state the domain and range. What's the equation of the asymptote and the y-intercept? Notice there's no graph. It doesn't ask you to graph. Some of you will be able to look at this and know straight away. I'm just going to do a quick sketch so I know what I'm thinking about here. There's not a lot of accuracy here, just a conceptual sketch here. So base graph of 2 to the x. There's our 2 to the x, looking something like that. And that's 1. 5 times it. Well, that'll go up to 5, won't it? And it'll be above it. So there we go. And our -3. That just moves our asymptote down from 0 to -3. There it is there, -3. And then that purple graph down is just moved down. There we go. Move that down 3, we're at 2. So here we go. There we go. So that's moved down from 5 down to 2. 0, the x-axis has moved down from 0 to -3. Everything's just moved down 3. So that blue graph is what I'm actually now thinking about. Okay, so let's now consider our domain and range. Our domain is, are there any restrictions on what x can be? Okay, well, no. You can get a value by putting any x, positive, negative, 0, into that equation. So our domain is going to be from -infinity to infinity. All right, our range. So I'm going to have a look at my range, and I want to look at, is there a minimum value? And I can head up that way. So is there a minimum y value? Well, yes, there is. It's -3, but it's an asymptote, so we never get there. So I've got -3. And what's our maximum y value? Goes up infinitely, so -3 to infinity. Right, what's the equation of our asymptote? Here it is down here. There it is there. It is the line y equals -3. And remember, if you just write -3, that is a number. It is not an equation. An asymptote is a horizontal or vertical line. It's got to be written x equals a number or y equals a number. Okay, and our y-intercept, well, our y-intercept went from 1 to 5 and then down 3. So our y-intercept finally is 2. Okay, you could have done that without, but I just like that visual cue to help myself. All right, something a little bit different. A little bit of function work here, a bit of composite functions. Okay, so let's have a look. We've got a function of x, 3 to the power of x plus 1. And we've got another function, g of x equals 2x. We want an expression for g of fx. Okay, so if you remember back to your function work, if we have g of fx, that means everywhere I see an x in g, I'm going to replace it with fx. So we now have, I'm replacing x with 2x. So I've got, oh, hang on, where are we? Sorry, my fx is 3 to the x plus 1. There we go. So I've now got 2 times 3 to the x plus 1. Okay, so my gx is 2 times x, and my x is now function of x. Okay, so you could write that as then 2 times 3 to the x plus 2. And then you could see what that would look like graphically. We're going to do one more. What about if we wanted this one? What about if I wanted f of gx? Well, this time it's the other way around. This time I'm replacing my g of x, which is 2x, into my function of x. So everywhere I see an x here, I'm going to replace it with 2x. So I've got 3 to the power of 2x plus 1. There we go. All right, guys, you've got some questions in the first exercise in that unit to do, and I'd like you now to have a look at the lesson for today, and I'll see you next period.